Hello, everyone, and thank you for attending today's webinar, Best Practices Checklist for Static Analysis in CI/CD. My name is Courtney Hendrickson, and I'm the Marketing Manager for Perforce QAC and Clockwork. Before we begin, I'd like to cover a few housekeeping items for our viewers. First, at the bottom of your audience console, you'll find a few widgets for questions and additional resources. When you have questions for the presenter during the webinar, click the Q&A widget and submit your question. We'll answer as many questions as possible at the end of the presentation, but if we run out of time, we will get back to you via email. If you need any technical support during the webinar, please use the help option. And finally, a copy of today's slide deck is available upon request. Please drop your email in the chat box or reach out to the team if you'd like to receive a copy of the deck. We'll email you a link of the recording following this webinar within the next few hours. And with that, I'll introduce our presenters for today. Steve Howard, Director of Product, and Gil Riddell, Senior Product Manager, both with Perforce QAC and Clockwork. Steve and Gil, thank you for joining us on today's webinar. You can take it from here.
Thanks, Courtney. So today's webinar, we're going to cover a number of topics around the idea of adding static analysis to our CI/CD pipelines. So we'll start with a quick recap of what we mean with CI and CD, and then we'll talk about adding static analysis. More complex topics then follow around how we deal with the initial baselines and backlogs that we may have at the start of the project, how we enforce the shift left, and then potentially how we even go to a further state of optimal left shifting using something beyond CI. And finally, we'll wrap everything up with a little bit of a checklist at the end so we can make sure we've covered all of those aspects off. And with that, I'm actually going to hand over here to Gil, who's going to start us off with an introduction to CI/CD. Gil.
Good. Thank you, Steve. So we're going to start with just a refresher on CI/CD. I think most people probably know on this webinar what CI/CD is, but we just want to make sure we're all talking about the same definitions. So very quickly, CI/CD is continuous integration. That's the CI part, where you've got multiple developers frequently merging their code into your shared repository, and then that triggers automated builds and tests. So that's the integration part. Then there's CD, and that's kind of a two-pronged thing, or two-flavor thing, I should say. So sometimes the D talks about delivery, which is the code automatically being prepared for release, or sometimes it's deployment, which is actually pushing the code to production without any manual intervention. So CI/CD has a number of key components. So the coding, obviously, which is where the developers are writing the code and committing the code into their repo, whether it's Git or P4. There's the build piece, which is where the system will compile the code and build all the artifacts that are required to make a deployable solution. Then there's the test piece, which is an important piece because you've got a lot of people that are merging code in here potentially. And so you want to have these automated tests in place to be able to validate the functionality and performance and the security aspects of your code. Then there's release. So you've got your approved builds that are staged for deployment. Sometimes there's automated approvals that happen. Sometimes there's manual approvals, but you have that release piece. And then finally deploy. So the code is pushed into production or sometimes into a staging environment. And that kind of completes the overall cycle. So when we talk about CI/CD, that's really what we're talking about. If we go on to the next slide, we look at what makes CI/CD improve your efficiency, right? So we're not just implementing CI/CD for the fun of it. It really is intended to improve your overall efficiency. So it provides faster feedback loops. So developers are getting early detection of issues and they're able to reduce their bug fixing time. It reduces manual work. So there's some automation that you're going to have in here, probably for building, testing, deploying, these types of things. And so that saves time, but it also reduces the amount of risk that you have that there is going to be some sort of human error. It shortens your release cycles. So teams can ship more frequently, features and fixes, which is important for the end users. It improves collaboration. So shared pipelines and visibility into the process helps developers, testers, operations teams, etc., all stay aligned. And all of that contributes to higher code quality. So this continuous testing and analysis of your code ensures a robust code base. So here's an example of a typical CI/CD workflow. So along the bottom, you'll see your master branch. And then the idea that we're showing here is you've got a feature branch that's been broken off of here. So maybe you've identified a bug or you're developing a new feature and you don't want to have it all going on in the master branch. You create your new branch, you work on the feature or defect. So that's in your, and then you commit those changes. And then typically you would have the CI pipeline run at this point. So make sure that the changes you've made are not causing any issues. Then you go into some review process where you've got peer review and making sure that things are committed the way that the team wants them to be. And once everybody's approved it, it can be merged back into the master. And then you have your CD pipeline run to make sure that those changes in combination with potentially other changes that have been merged since you made your branch are all running as expected. So that's the main workflow. Now we want to look at what happens if you want to add static analysis into the mix. Okay, so let's look at what is static analysis. So static analysis or static application security testing, it's the art of processing the code. So sometimes it's the raw code, sometimes it's in binary format, to derive valuable information, normally code defects. So the code itself, the important thing about static analysis is the code itself isn't actually executed. It's a simple lint-like static analysis. So it's kind of like a file-based or a unit testing process. And then there's deeper interprocedural analysis that can happen, which is more like integration or system testing. So static analysis is great for speed. So it doesn't require dynamic execution of your code, so it can operate quite quickly. Coverage, it effectively runs through the whole control flow of the code. While not executing it, it does follow the code to make sure that it all makes sense. It finds issues in the paths not considered, so negative testing. And it finds issues early in the software development lifecycle, since it doesn't actually have to run the code. So if you're looking for your ideal static analysis solution, at Perforce, we've got two solutions. We've got Clockwork and QAC. And there's a couple of key things that you want to look for in this solution. So initially, you want to ensure that it's safe, secure, and that you're delivering safe, secure, and reliable code. So it's not just security, but reliability that's also at the heart of this. And that can be enforced through standards such as MISRA, et cetera. It helps with generating compliance reports for your standards. So this is important. It can be an often tedious or manual process. So you want to make sure that your static analysis tools are able to help to automate that and align it with your internal or industry standard needs. There's continuously monitoring of your code. So you want to make sure that your static analysis is injected in the right places so that you can monitor your code at all of the stages that we've talked about in the CI/CD workflow. And then the last couple here, so training your developers as they work and providing rapid feedback to developers. These kind of go hand in hand. Developers would receive contextual warnings and hints directly in their IDE, and that helps them to learn and to develop best practices in real time. So if we look at the benefits of static analysis in CI/CD pipeline, well, first of all, the static analysis tool is really acting as a gatekeeper. So it's ensuring that only your high quality code makes it into production. So some of the benefits of that, so you've got automated quality checks. So every commit is scanned for issues. It enforces your coding standards and security policies. You've got consistent enforcement. So rules are applied uniformly across all the contributors. So there's no human error or no room for human error in there. It's being consistently enforced. There's security assurance. So vulnerabilities are flagged before they're deployed. It helps the team stay compliant and secure. And then faster time to market, which we've talked about a bit already, which is you're catching these issues early. And so that helps to reduce the need for any hot fixes or rollbacks in the future. So all that makes the pipeline integration, uh, the pipeline integration ensures the quality is not just a developer's responsibility, but it's a team-wide commitment. So when we talk about static analysis, and we've talked about it in a couple of different places, here's kind of a graphic of where we see it fitting. So if we start on the right-hand side, so you've got your full baseline scans. And so that's happening after all of the design and build and unit testing has happened and the system builds. So you've got that final check of the baseline. If you pull it a little left, then you've got your CI delta scans. And this is happening as you're working on your individual branches and making changes for feature introduction or defects. You've got your CI delta scans happening there. And then further back from that, or shifting further left, you can have desktop scans. So while the designers are actually implementing the solutions, they can be performing desktop scans to help to catch those issues early and prevent them from being caught further down the line. And so this chart is really showing a cost to resolve defects. And so as you can see, the further left you shift on the line, the more cost effective it is to fix the defects. And so if we were to look at that in our standard workflow that we looked at earlier, the first point is your desktop scans on the left. So that's happening when you've created your branch, you've committed your changes, or you're ready to commit your changes. You can do your desktop scans to make sure that before you commit that code out to the out to your repository, that you've scanned it and make sure that all of the defects are caught. Then there's the actual check-in, so you can check it into your repository, and then you can run your Delta scan or your CI scan. And this will just ensure that there's no additional defects that have been introduced. And then finally, there's the CD, the full baseline scan, which was further up on the chart that we looked at previously. And this is where we're actually testing on the master to make sure prior to release that there's no further defects being introduced. So introducing static analysis, it's kind of an evolution, or there's different maturity stages for it. So there's a number of things you need to do. So you need to, up front, you need to define what are your SA rules. So you need to have a set of rules this is going to differ from company to company, but you need to look at what are your development standards, what are your coding guidelines, security policies, compliance requirements, etc. So you need to consider all of those things which go into defining your SA rules. Then you can look at adding SA into your CD pipeline. So again, this is just before it goes out the door, you're checking to make sure that everything is okay. Prior to or after that, then you may want to start to looking at baselining your code and starting at zero issues. So we're going to discuss this a little bit more. And in fact, we'll discuss all of these a little bit more detail later on, but it's really just making sure that you're preventing new issues from being introduced. So you're baselining your code and making sure that you understand where you're at before proceeding with new developments. Then you can look at integrating your SA into the CI pipeline. And this is where you're starting to look at all of the branches and pull requests to make sure that you're scanning all of those for issues. And then finally, you can add some CI quality gateways or gates to enforce accuracy. So you can make sure that when you are scanning your code, you can set thresholds and say, okay, if we've got a certain number of defects, then we're going to fail this release and we'll have to go back and address those issues as an example. Okay, so if we look at the first one that we talked about there was defining the rules. And so there, as we mentioned, there's a number of things that you need to look at. So, and some or all of these may apply to you. So there's quality, right? Do you need to look at, are you interested in tracking your long-term stability, reducing technical debt, etc.? So all those can fall into the quality bucket. There's security, right? Do you have defect vulnerabilities? Do you want to catch defect vulnerabilities early, before they reach production? There's safety. Do you want to ensure that the software behaves predictably under failure conditions, right? And then there's coding standards. You may have, depending on your industry, you may have certain industry coding guidelines that you need to meet, like MISRA or CERT, etc. And so all those things are considered, all or some of all of these things are considered when you're putting together your rules. So the next steps will be covered by Steve. I'm going to hand it off to him, and he'll start off by talking about the baselines and backlogs.
Thanks, Gil. Okay, so the first thing, as Gil said, is to define our actual rules. Now, inevitably, once we've done that and run our first full analysis of our code base, we're probably going to find that it's not perfect. Often there are cases where we have too many findings. Really, that is the most common. We got too many findings to deal with, perhaps, or just a huge amount of backlog. Or in some cases, we might find very little, and so okay, we can tune this up a little to make sure we're finding a little bit more, perhaps. Or there may be certain types of issues that seem to be repeated rather regularly. Something that's caused by a systemic failure of some kind of rule because of the way we code, maybe, and so on. There's lots and lots of these that we might find in that initial baseline analysis. So we do end up in this little bit of a sort of a wash, rinse, repeat cycle for a little while as we begin, just trying to really tune the goals that we have and define rules that match to those and that are realistic and will be effective. There's no point really in having too many issues that are of too low a value, because the developers will become tired and perhaps not follow them. Maybe we've got standards that we have to follow that really do make it mandatory, and therefore we have no choice. But in general, it's about getting this right, finding the right point. So once we've done that, the idea is that we can then start to release this information to the development community that we have. Now, the last thing we want to do, as we said in the previous slide, is to overload our developers with lots and lots of data that really isn't of interest. And that's really important when we're first starting. Ideally, we'd really like to start with 0 issues, because then the developers don't feel like there's this huge mountain they've got to even start to climb when we first bring these tools into their environment. We want them to get comfortable. We want them to start feeling that this is going to be useful and detecting new issues as they then start going along, rather than giving them a whole stack of new work to begin with. So what that means is we have to baseline, as we call it. We have to start from a point where we push a number of the issues that may be ones we want to deal with at some point into a kind of a holding state or some kind of process for dealing with those later. And that will allow us to, with this backlog taken out, to really focus on the new issues and what we call stop the bleeding, stop new issues, new technical debt entering the code stream, because that will give us more time later on to deal with that backlog. So we're going to triage them and process them in some way. There's lots of different ways we can do this. We can, for example, start with 0 issues. Just say, okay, everything that's not, or everything that we have in this initial analysis, we're going to put in the backlog and we'll deal with it later. But we may also want to divide them into different groups and sort of treat them slightly differently. And here's an example. It's quite a complex example from a real world case, actually, a real world customer that came into us and said, okay, lovely, we've got this project, it's huge. And we probably haven't done all of the analysis we should have done. Parts of this have been released in different legacy projects already, and we know those are safe. But we have some new security concerns. So we really need to look at all of this. And what we did is we took the first analysis and ended up with several 100,000 issues. In fact, in this case, it was on a very, very large project. And that's obviously too many, far too many for our development group to deal with. But the first stage was to pass this through to the security team. So a lot of this was led by the CISO, and there was a number of packages and code repos that came into this that actually weren't belonging to that individual customer. And so the idea was that these would automatically be suppressed. We don't need to worry about these because they're not something that's in our code. That we may be interested, but largely we're having updates of this for the security issues. They're doing that from the people providing it, so we don't need to worry. So those would be suppressed and removed from the backlog, and similarly test code as well, which was also in the same repository, was removed. So all of that went out straight away. Once we got down to a subset, which was the code largely belonging to the customer and the development team, we then separated them based on their issue type. So were they a safety related issue or a security issue, depending on which standards they fell into. Security was a major concern at the time, and so security was the one that kind of got dealt with immediately. And then based on severity, anything which was flagged as a sort of a high severity issue by the standard, and I think in this case it was sort of CERT, so the CERT L1s perhaps, those were marked as critical issues, and therefore those were forced straight into the initial baseline, and the developers would see those when they started work. So we had some issues. But once we'd done all that filtering, it was a very small number, a few hundred, across the whole development team. So in fact, it wasn't a major task, but it was things that the developers would recognize as really critical issues that they needed to solve. So it was very much a positive thing. For the rest of the issues, if they were safety related, they went through a further processing depending on whether they were from those legacy projects and already out in the field, and also from the security side, the lower severity issues were put into this sort of holding database. Essentially, we're just keeping hold of those and waiting for the management team to say, okay, we've now got a little bit of bandwidth, so we'll take some of those, the high severity issues or the ones that were most safety related, and bring those back in. But that wasn't something at the start. We just put them into that backlog. So the backlog can be measured and monitored, and of course all handled by our tools in Clockwork and QAC. But you could also use your own tools for that, things like Jira, where you just push any of the issues that you weren't dealing with immediately onto the Jira backlog, essentially, and manage them with a proper change control process through something like that. So that's our baseline done. Once we feel we're ready to release, we obviously put the tool into the CD pipeline then at that point, and we start providing the results as a way to measure the quality. But after that, we want to try and shift left. So this is the sort of the next level of maturity. And really the reason for that is, of course, that when we're talking about coding errors, the likes that we find with our static analysis, the majority of those are actually created, of course, at coding time. So the issues that we tend to detect from the static analysis side, and also from testing, in fact, is all generally around the things we're introducing into the code. And those are detected as we go through our normal process of testing or analysis. And you can see on the Capers-Jones graph here, example of the productivity versus the quality of the code versus cost of fix and so on. That's what it's showing us here. And we have the different stages of kind of the V model right hand side, coming up with the different levels of testing, going along the x-axis, and then the number of defects being introduced and then detected on the y-axis upwards. And of course, the cost to fix, as we showed earlier, is always increasing as we go through these stages. And this is what we'd normally see. So normally, the unit testing and functional testing, system testing, each level, we're going to detect more of the issues as we get through those. Hopefully, we detect all of them and nothing's released into the wild, but that's not always the case. So we're here now. We now have our CD pipeline. We have our results. We're not forcing anything to get blocked at the moment. We're just measuring what's happening in our analysis. And so the next step is to introduce our analysis into the CI. And why would we do that? Well, the reason to do that is because it shifts left. It now brings our detection of issues, and hopefully using a quality gate, we'll actually block merges based on this. from going into the master branch, we're going to shift those detection points earlier in the cycle. In fact, as soon as we finish coding and committed, so within that normal post-commit process. This is being automated, of course, now in our world by the CI tools. And so what we're talking about in terms of the graphic we saw earlier in terms of where this sits in the cycle. So we've started with our full baseline scans, and we're shifting left by bringing our analysis further down the sort of the path into the feature branch, as Gil mentioned before, post commit of the changes, but prior to merging. So this is really an optimal point. And we could, in fact, also run those CI scans, of course, with every commit if you wish to. So in other words, if we run it with every single check-in, every single merge, whichever, both in some cases, really what's happening is our continuous integration, which was detecting build problems created by those changes, is now additionally checking for coding issues, compliance problems, security vulnerabilities that we're introducing with those changes as well. So it's adding an extra level to what was already continuous integration and making it continuous compliance. At that point, I'm going to hand back to Gil to talk about going further with our optimization.
Excellent. Thank you, Steve. So Steve has covered already the full baseline scans, and we've looked at the Delta CI scans. So the next step in our optimal shift left plan is to have desktop scans. So that's what we're going to have a look at here. What's the benefit of doing actual desktop scans? Desktop meaning it's actually happening with the developer in their IDE before they commit their changes. So we're looking at the same Capers-Jones graph, but now we're looking at what happens if we do pre-commit detection and remediation. And so you can see the orange line, which is indicating where the defects have been found. Now we're finding defects much earlier in the cycle. And by finding them much earlier in the cycle, you can see by the red line that the cost to repair those defects is much lower. So we're getting a benefit of reduced cost for fixing these defects. And you'll even notice that there's a reduction in the actual number of defects that are being found here, mainly because they're being found before they're even committed to unit test. And the developers are learning as they go here as well. So if we go on, let's look at some of the benefits of static analysis at the desktop. So I mentioned before, static analysis at the desktop is really talking about integration with the developer's IDE or their pre-commit workflow. So that this is what we would call the optimal shift left process, where we're catching issues before they're ever even committed to the repo. So the benefits of that obviously are immediate feedback. So the developers are getting real-time insight into their code. And there's little to no context switching. So as they're working on the issue and they run their analysis, they immediately get the feedback. There's no having to go back and say, what was I working on there? What was I thinking? So it's all immediate feedback, which is very useful. That lends itself to improved code quality. So this early detection of bugs and anti-patterns leads to your cleaner, more manageable code. Faster reviews, so you're fixing a lot of the issues up front, and the reviews can be focused more on the logistics of what you're trying to do, and not so much focused on the structure or some of the things that the static analysis may have caught for you. And this empowers the developers, right? So the developers are actually taking ownership of their code quality, masters of their own domain, if you will, right? That fosters a culture of craftsmanship. And so now what we're saying is we're embedding this static analysis into their workflow. It reduces their cognitive load, and it helps to prevent issues from snowballing downstream. So, okay, so we've got the developer now scanning their code. What else could we do? Well, Another thing we could do is we could introduce AI at the desktop to help with remediating some of these issues. So up until now, we've been using static analysis just to detect the issues. But now we can use AI to help us go beyond detecting the issues, and we can look at intelligent resolution. So within our Perforce tools, we do have this capability, and some of the things that enhance the developer experience within the AI is the ability to leverage the analysis results. So the results of the AI are really going to be dependent on how good the input is to the AI. I think we've probably all had some experience with AIs, and if you give it bad input, you're going to get bad output. So we can leverage our analysis results. We've already gone through the code. We've done the in-depth analysis with either our Clockwork or our QAC tools, and we've got a really good understanding of what the issue is. We've got solid documentation around how to identify that issue, how to fix that issue. And so we provide all of that in-depth analysis information to the AI to help it to develop some sort of intelligent code remediation suggestion. It's all context aware, meaning that as you interact with the AI, you can it remembers what you've been working on. So if you've asked it to fix a particular defect, you don't have to restate anything about that defect as you interact with it. Maybe you want to add additional comments or something. You don't have to restate what you've already stated. The AI remembers what you're talking about. We've got automated reanalysis. So you've got the ability that the AI is going to recommend a solution for you. You can automatically reanalyze the code because you've got that capability at your desktop. You can reanalyze and confirm that number one, it fixes the issue, and number two, it isn't introducing new issues. So you've got that immediately at your fingertips. It's all developer controlled as well. So the AI isn't doing anything on its own per se. It is giving you a solution, a recommended solution, but it's up to the developer to look at that and understand, yes, this is what I want. It's integrated directly into your IDE. So in the case of our solution, it's integrated in with VS Code. And so it's a very smooth workflow for the developers to utilize this capability. And it provides flexibility in your LLM. So you've got a wide range of AIs that you can select, including local LLMs. So you've got a broad flexibility there that you can take care of. And what this means is we're really transitioning or transforming static analysis from just being a reactive tool, so not just looking at detection, and moving it more into a collaborative coding assistant. So I've got a sample here just to show you quickly what it would look like. So we've got a VS Code window open here. We've got a project that we've loaded in, and we've already run our Clockwork analysis on it. So the analysis will list all of the problems that it's found down in the problem window. And you can simply just select any one of those problems and right click on it, and a pop-up window will come up and ask you whether you want to fix that issue using the Clockwork tools. This also works for QAC. So if it was QAC, it would say fix using QAC tools. So you simply select that. And by selecting that, it's going to kick off the remediation. And so there's a few things that are happening on this slide. On the far right side, you'll see a chat window. And in here, there's kind of a running commentary of exactly what the AI is thinking, what it's doing. It'll give you a summary of the issue as it understands it. It'll give you a summary of the fix that it's recommending and why. And then it'll give you maybe a little summary of what it's preserving in this case. So it's making sure that it's preserving the error handling and the style and formatting, etc. So it gives you that running commentary on the right-hand side. And in the center, it will bring up the file that has the issue that you were trying to fix, and it will put in line the proposed fix. And so you can see here that the lines in red would be deleted and the lines in green would be added. So you have the ability as a developer now to either keep that. So if you look at the individual fixed controls that are highlighted there, you have the ability to keep that, or you can undo it, meaning you can discard it. Or you have the ability to go into the chat window and interact with the AI and perhaps ask for maybe additional changes, or maybe you want to say, yes, I'm happy with this. Please add detailed comments into the code explaining why you made this change, etc. So you've got that interaction with the AI as well. So that's just a final or a quick review of how that feature works within Clockwork and QAC. So I'm going to hand it back to Steve now to go over the summary of what we've talked about, as well as talk about a checklist that you may be finding useful.
Thanks, Gil. So yeah, bringing it all together, really, static analysis is not really just a tool. It's trying to enforce an entire mindset shift, really. And the idea is if we can use it effectively across both sort of our day-to-day coding work and also within the CI/CD pipeline, it's going to make sure that we reduce our technical debt in the long run. It's really going to enhance our security posture, or making sure we've not got those vulnerabilities slipping out into the wild. It's going to improve our productivity, and hopefully all of that will mean also that we accelerate our delivery cycles. Using static analysis in the pipeline will help us because it's going to automate those quality. We've got those quality gates or security gates, whatever you want to call them. We have consistency of enforcement, and also we know that when we are doing that enforcement, we're using something that's centralized, it's known, we can reproduce it, etc., etc. All of the benefits of CI/CD pipelines in general. By then moving to the desktop, so shifting further left, optimally shifting left, we're able to give our developers immediate feedback on the issues they're creating. And of course, that in itself means that we then spend less time downstream again, because we have less rework, we have, quicker reviews, there's less to actually look at. And also it brings the developers very much into the whole process. So there's a lot of empowerment there for the developers as well. They learn as they see the kind of issues that are being detected and explained, and they can see why and how to fix them as well with AI on top of all of that. So really it brings everything together rather nicely there. And another thing about this is if we start to enforce those rules within the pipelines, the developers themselves, they don't want to be responsible for we've seen it anyway with, the person who's broken the build in the CI. Nobody wants to be that person when it comes to the wider dev team. And so it almost encourages them to use these desktop tools. And finally, as we said in the last section there, if we have that additional benefit of having AI remediation in the desktop tools, because it's still within the developer's workflow, they're still very much involved and working with the AI, it gives us that speed and performance improvement further within that cycle, and hopefully very much producing high quality code that's been checked and confirmed and pushed through. So just to summarize, the steps that we think you should go through ideally within the pipeline itself. So we're very much starting with the baseline scans at the end of the process. That's where we have to begin, because we want to make sure that centrally everything's working, we're getting the right results, and we reviewed those and approved them. Once we're happy with that, we shift further to the left, and we're really now bringing it into the developer's world. And so that's why it needs to be right. We don't want to waste their time. We want them to be seeing high quality and correct results for appropriate levels of requirement. Once that's working and we're enforcing quality gates based on those results as well as breaking or not breaking the build, then the developers themselves will likely want to adopt that further stage of actually bringing the scans to the desktop, because then they know that when they commit, they will be committing very good code ready for merging. And it encourages all of that in one go. So as a final summary of the checklist, the first stage, as we mentioned, of this sort of evolutionary process or maturity process of going through this, we've got to start by defining the right rules. We've got to know what it is that we have to do. Are we required to deliver standards-based compliance such as MISRA, or a security-based standard like CERT or CWE rules or OWASP? And then once we have those, how we're going to enforce them? Are we going to enforce all of them? Are we going to enforce just the higher severity rules or the mandatory rules from MISRA and the required rules from MISRA and not the advisory? That's a decision we have to make as a team centrally, because we have to pick an appropriate level for the project that we're working on. But all of that helps us to focus, of course, already on the quality, the safety, and the security. Once we've added that requirement and those rules to the CD pipeline, we're now starting the process of enforcement. We start to measure results, and we can see what level we're getting. Again, this is part of that evolution of just making sure we're hitting the right mark here. Once we've got that right, we create the baseline. So this is where we're trying to start from a very low number, or from the ideally 0 findings, so that we're focusing the developers from that point forward on new technical debt. Nothing to do with the old. We can move that to the side, deal with the backlog separately. That comes later. We want to focus on not making things worse. So we then start, once we have that baseline, bringing the static analysis into the CI pipelines. Developers get visibility. It's in their daily routines. And at that point, once we're comfortable that that's working correctly, we can turn on the quality gates, and that's the enforcement piece. So finally, we're now blocking new technical debt, new security vulnerabilities, new failings of our coding guidelines or standards or safety standards that we need to meet. Those are stopped before they even enter the code base in the master branch. And of course, after all of that, there's an additional option to add pre-commit analysis. It's optional, but it's optimal shifting left, because this brings the process of finding and fixing to where the issues are actually created. And with that, I'm going to hand back to Courtney for some questions. Thanks, Courtney.
Absolutely, thank you. And we do have several questions here. Let's see, the first question is, for tons of legacy static analysis findings in embedded systems, how do you figure out what to tackle first?
Okay, yeah. So the first, yes, you're right. And I think this was the point around the baselining and dealing with the backlogs and so on. We very, very rarely start from a project with 0 code. So we're always going to have some level of legacy system that we're working from. And in fact, that's very common. We have a legacy project maybe that's coming around for a new piece of development, or we're starting from that old project as a base. How can we separate those issues? So first of all, we can baseline and actually just take all legacy issues. Anything that's in that legacy project can be put to one side. And that might be sensible, because it might be that system has been running out there in the customer base for many years, and we know it's secure, we know it's reliable, so we can trust it. And maybe at that point, even if there are some issues, maybe we say, well, that's fine. We're not encountering them day to day, so we don't need to worry about it. But we do want to worry about every new issue that we create, either in that code or in any other code that we're adding. So new issues don't just come in the new code. It's possible that by changing code around the original legacy system, we're also going to break something inside that code base as well. So there's a lot to this, but yeah, generally the idea is that we can do that baselining and then work from there.
Excellent. All right. Next question here. What kind of metrics should QA teams be looking at to see if SA is actually helping over time in CI/CD setup?
Okay, that's another good one. And so the one that springs to mind, obviously, is we can measure how many issues we're finding in our testing process, or hopefully not, but possibly even what we're getting reported from our customers, and see that actually those metrics are showing an improvement. So that's the acid test, of course, to make sure that we are actually finding issues that otherwise would have been found in testing or would have been found in the wild, and that would have cost us time and money. But from the static analysis side as well, we can actually detect where we find those issues. So again, our baseline is our starting point, but how many new issues are we finding that make it through to that master branch? Hopefully, again, the answer is 0, because we're cutting them off, but that's a good metric that we could certainly use. Gil, I don't know if there's anything else there you can think of.
No, you're doing fine. I'll just eat my popcorn and listen.
Thank you very much.
All right. We do only have time for one last question here. That being quality gates. How do you decide what counts as a failure in safety critical pipelines?
Okay, well, I'm on a roll now, so girls, let me have it. I guess that very much depends on those rules and what you're trying to work with. So many of our customers have to actually show compliance to standards. For example, if we take the MISRA standard, in the MISRA sort of guidelines, it will say, okay, well, you've essentially got to fix the issues that are mandatory issues. You can apply a deviation to required rules, but ideally you want to be fixing those. And then there's also the advisory level or categorization as well within that standard of rules. And so you can actually distinguish even at that level of categorization from the standard itself and say, okay, well, in our quality gate, if it's a mandatory or required rule, we've got to fail. Something's got to be done. Whereas if it's an advisory an advisory issue that gets reported from one of the rules, that's acceptable. So we can actually define our quality gates based on even that level of granularity, within the standard. And it's not just MISRA. We also see that with some of the security standards like CERT, where we have the level 1, level 2, and level 3 distinction as well. And it's, by the same token, we could use those as a decision factor. Or we can just simply say, if you have any issues, it's a problem. Or we could say, if you have any issues of a certain severity, it's a problem. And so there's lots of options there. But yeah, we've got lots of flexibility, and that's the right thing because the projects themselves have lots and lots of different requirements. And there you go, a full sweep.
Excellent. All right. And with that, we are out of time. Thank you very much, Stephen Gill. If we didn't get to your question, we will reach out to you via email. Shortly after this presentation, we will be sending out the checklist that Stephen Gill walked through so your teams can easily reference it as you put each step into action. Thank you for our audience for your attendance and participation today. And of course, thank you to our presenters. We hope to see you next time. Thank you.
Great, thank you.